Right, so welcome to this class, and in this class we are going to be looking at logs and indices. So the questions here are coming from the tutorial sheet. So logs and indices, what is our objective of this class? So at the end of this class, you must be able to evaluate logs. You must be able to solve equations that are involving indices, and then you must be able to simplify logs and also to come up with logarithmic equations in order to solve some of these questions that we're going to look at today. So if you have any questions at any point, just unmute yourself and then speak, and then I'll attend to you. All right, so let us look at the first part that we're looking at today. And then this first part says, given that the log, that is log base 7 of 2 is equal to 0.356, and log 7 of 3 is equal to 0.565, like this. And then they're telling us now that we must find the value of what of the following logs. Find the value of what of the following logs. Okay, so how are we going to do this in order to find the value of those logs that are given there? So we have the first one is given as log base 7 of what? Of 8. And then they're telling us to find the value of this here. So now to evaluate, I'm going to have to simplify. From this 8 here, I can get what? I can get a 2. So I know if I write 2 to the power 3, this gives me 8. So I'm going to write this as log base 7 of 2 to the power 3. And then by the laws of what? Logarithms, I can drop this 3 here, and then it becomes log base 7 of what? Of 2, like that. Okay, and then I already know what my log 7, log base 7 of 2 is. It has been given there, which is just 0.356. So it's been given as 0.356. And then that when I multiply the 3 multiplied by 0.356, I just get this to be equal to 1.068. So this here is what is the value for the first one. Okay, so let us now look at the second one. So for the second one, we have log base 7 of 54. So we have log base 7 of 54. So how are we going to do this one? So for this one, we notice that this 54, so the 54 can be written as what? This 54 can be written as 2 multiplied by 3 to the power 3. So 3 to the power 3, 3 to the power 3 gives us what? 27. So this here is 27, and then 27 multiplied by 2, you get 54. So I can write this 54 like that. So if I replace here, I'll have log base 7 of, then you have 2 multiplied by 3 to the power 3. Okay, and this now, again, the laws of what? Of logarithms, which we looked at in the previous class. So those laws, they're telling us that if we are multiplying two logs like this, you can separate them just by an addition sign. So you're going to have this is going to be equal to log base 7 of 2, then plus log base 7 of what? 3 to the power 3. So I can separate that since it's multiplication. And then this is going to be log base 7 of 2 plus, then I can drop that 3 there. So when I drop that 3 there, I'm going to have 3 here, log base 7 of what? Of 3. And then I can replace, since I know log base 7 of 2 is just that there. So here I'm going to have this will be 0.356, and then there I'll have 3 multiplied by there, which is 0.565. Okay, and this here is going to just give me, this will be equal to 0.356 plus, so I multiply 3 multiplied by 0.356, and that there is going to, okay, so 3 multiplied by 0.565, and that there is going to give me 1.69. 5. So I get that to be 1.695. And then here I just add the 2. So I add plus the 0.356, and then I just get that my answer is 2.051. Okay, so that's what I get for the second one. All right, so as I said, if there's any question at any point, just feel free to unmute yourself, and then you can ask. All right, let us do the next one. So the next question tells us we have log base 7 of what? 2 over what? Over 3. Okay, so now here we have what? We have division. So now when we have division, according to the rules of logarithms, we can just say this is log. I can separate them, base 7 of 2. Then I will separate with what? A negative sign. And then log base 7 of what? Of 3, like that. Okay, so this here is just going to be, this side I can replace with the 0.356, then minus the other side I can replace by 0.565. Okay, so when I subtract these two, so I punch that into a calculator, I have 0.356, then minus 0.565, and that there is going to give me that this is going to be equal to negative 0.209. Okay, so this is what I get for the second one. Okay, let us evaluate this last one. So there, what are we going to have? So we have log base 7 of 4.5. So I can write this 4.5 as a what? As a fraction. So this 4.5 as a fraction, I'm going to have, so I multiply this by what? By 10, and then divide. So I'm going to have that would be 45 over what? Over 10, like that. Okay, so this here just simplifies to 9 over what? Over 2. So the 9 over 2 here is what? Is the 4.5 there. So now I'm going to replace there, say log base 7 of 9 over what? Over 2. Then since it's division, I know I'll do just what I did there. So that is log base 7 of 9 minus log base 7 of what? Of 2. And then this here 3 I can write, the 9 I can write as log base 7 of 3 to the power what? To the power 2. And then there I still have log 7 of 2. And this here, the 2 I can drop like there. Okay, and this is going to be equal to 2 log 7 of what? Of 3 minus log 7 of 2. Now I just replace. So this is going to be equal to 2. There I have that this one there. So I'm going to have 0.565, and then minus the other side is just 0.356, which is there. Okay, so here I'll have 2 multiplied by 0.565, and this here is going to give me 1.13 minus there the 0.356, and this here I subtract 0.356, I'm going to get that this is going to be equal to 0.774, and like that I have found the value of of these logarithms. Okay, is there any questions so far? Okay, so there's no questions. All right, so let's move on to the next part. So the next part here is telling us that given that the log a of m, so a of m, so this is what we must remember here. We're just applying the laws of the logs which we have which we have already looked at. So those we learned that first of all, when you're having two of the same base, but there we have two that are multiplying like this, we can separate this as log base a of what? Of b plus log base a of c. And then if we have log a, and then we have b over c there. This will be log base a, and then b minus log of a, then c. And then if you have log a, and then you have b raised to a certain power, let's say n. This here allows me to drop the power in front to be log n, and then you have log a of what? Of p, like that. Another rule, just in case you have forgotten, is log a of a. This here is going to give me 1. And then log a of what? Of 1. Log a of 1 is going to give us what? 0. So any base that you're going to use, as long as you're taking the log of 1, it's going to give you what? To give you 0. Okay, so I hope that has refreshed your memory on the what? On the laws of indices. So now let us answer now the question. Again, just we're applying those same what? Those same laws. So they're telling us that given that log a of m is equal to p, and then log a of n is equal to q, express the following in terms of what? P and q. So I have to express in terms of p and q. So the first one I have log a, that's the base of m squared and then n. So here m squared and n, those are what? Just multiply. So this here is going to be log, I maintain the base, and then I say m what? M squared. Since it's multiplication, it's going to be plus, and then I say log base of a, and then what? N, like that. And then here I can drop that 2, so that I have log a of what? Of m, and then plus that log a of what? Of n, like that. So this here is going to be my log a of m is just what? P. So there I'll replace what? I'll replace P. And then log a of n is just what? Q. So there I'll replace Q. So this is just equal to 2P plus what? Plus Q, like that. Okay, so this is how you would find this one. All right, let's do the next one. So the next one you just have log. So you have log base a of what? M squared over what? Over n. So this here is going to be log, I separate them. So a, then I say m squared. Since it's division, meaning I'll be subtracting, so that will be log a of what? Of n. And this here is going to be log, so the 2 comes there, and then a of m there, minus log a of what? N. And this is going to be 2. So here where there's log a of m, you just put p there. So that is going to be p, and then minus where there's log a of n, that is q. So you have q there. And just like that, we have found our answer. All right, let us move on to the next one. So the next one, if there's any question, feel free to ask. So you have log, and then the base is a, and then yeah, you have that which is a to the power 3, and then you have, so a to the power 3, and then you have m, and then divided by m what? M squared. Okay, so let us work out this one. So this one is just going to be equal to log base a, and then you see you're dividing here the term that is on top and the one which is down. So you're going to write the one which is on top first. That is going to be a to the power what? 3m, and then minus log what? Log a to the power of what? M squared. Okay, so now here you see you have a and what? A to the power 3 and m. So you can separate this since they are what? They are multiplying. So you can write this as log a of what? A to the power what? To the power 3, and then plus log a of what? Of m, like that. Then you have minus there log a of m squared. Now I can drop this power there to be 3, and then you have log a of what? Of a remain, and then plus log a of m, and then you have log, so the 2 there drops, so you have 2 there, and then log a of what? M. So this here is just going to be, so here you see that you have log a of a, which is just 1. So there you remain with what? 3, and then you have your 1 there. Plus you have log a of m, which is just p. So that will be p, and then you have minus there 2 log a of what? Of m is also what? Just p. And this here is going to give me 3 multiplied by 1, I get 3, and then you have p minus 2p. So that is going to give me negative what? Negative p. Okay, and that's how I find my answer, like that. All right, let's move on to the next part, or the next question. How do we solve the next question? Okay, so the next question, to erase here. So the next question is going to be, so there you have log base a, and then you have the square root of mn. So I can write this as log base a and there I write mn, and then you have to the power what? To the power half, since that's the square root there. And this here is going to be, I can drop the power such that I have log half, and then log what? Log a, and then you have mn there. Okay, so mn, those are multiplying, so I can separate them such that I'll have this here to be log a, and then m plus, since it's multiplication, and then log a of n, and then I close. So there I'll have half is equal to, so log a of m is just p, so I get p there, plus, and then log a of n is what? Is q, so I get q there. So this here is just going to be, if I multiply, so that's just, I get p plus q divided by what? Divided by 2. Or you can leave it the way it is, as half p plus what? Plus q, like that. Still the same what? The same thing. Okay, so this is how you would express this in terms of p and what? And q, just using those same rules of what? Of logs that we have what? That we have learned. Okay, so what do we do next? So next we have these questions that are here. Okay, so if you have any question, as I said, just feel free to ask. So they're telling us to solve for the value of what? The value of x. So we must solve for the value of x. So how do we do that? So for the first one, you have 3 to the negative x, and then is equal to what? 81. So here you can notice that this 81 can be written as, so 81 can be written, or is equal to 3 to the power what? The power 4. So meaning we're multiplying 3 by 3 by 3 by what? By 3. And that gives us what? 81. So I'll write 3 minus what? X, like that, and then it's equal to 3 to the 4th. And since they have the same base now, I can just equate their what? I can equate their exponents. So I'll get x there is going to be negative x is going to be equal to what? To 4. So therefore x, I divide by negative both sides, I get negative 4. So my x is just equal to negative 4. Okay, let's move on. So next we have 9x plus 1 is equal to 729. So you have this here, and this here, what is it going to be for us? So this here is going to be, I can write this 729, I can write it as so that 729 is just 9 to the power what? To the power 3. Okay, so I get 9x plus 1 is equal to 9 to the power 3. Then I can just, since they have the same base, I can equate the what? I can equate the exponents. So I have x plus 1 to be equal to what? To be equal to 3, such that my x is going to be equal to, the positive 1 goes the other side, the additive inverse, it becomes negative 1. So we have 3 minus 1, and this here is equal to 2. So our x is just equal to 2. So the value of x there is just 2. Okay, let us find the next one. So next you have 4x, and this here is equal to 0.25. You have 4x, and this here is equal to 0.25. Okay, so how are we going to write this? So this 0.25 here, if I move the decimal, that is 1, 2, there, I'm going to have that this here is just 25 over what? Over 100 equal to what? 4x. I mean, the x is an exponent there. So it's equal to like this. And this here simplifies to 4 to the power x equal to, you have 1 over what? 1 over 4. And then I can write this as x equal to 4 to the negative what? To the negative power. This 1 over 4 I can write as 4 to the negative power. Then now, since they have the same base, I just equate the exponents. So I have x equal to negative 1. And that's my what? That's my answer. Okay, let us do the next question. So what is the next question? So the next question is there, and we have that as 5 negative 2x is equal to 1 over 7 to the 720 what? 25. Okay, so here there are either two things. It's either this question is right the way it is, or they made a what? They made a mistake on the question. they should have written 25. So I'll take it in both ways. So if they had written it as negative x is equal to 1 over 625. So 625, I know that 5 to the power 4 gives me 625. So I could have written this as 5 negative 2x is equal to 1 over 5 to the 4th. Then here I can write as 5 negative 2x is equal to 5 to the negative 4. And then I just equate the exponents since they have the same base. So it will be 2 negative 2x is equal to negative 4. Divide by negative 2 both sides, I get x is equal to what? To 2. Okay, so this is if it was like this. But then let us take it the way it is. The way it is what it has been given. So the way it has been given. Okay, so for the way it has been given, meaning you're going to say log. So you're going to say the 5. Okay, so let me just rewrite that. So you have 5 to the negative 2x is equal to, so that 1 over 125 I can write as 725 to the negative 1 power, like that. Then here I can take the what? The log, or I'll just use base 10. So base 10, they do not usually indicate the what? The base there. So it's usually just like that, but you know that it's base what? Base 10. So you take this log and then to the negative what? 2x, and the other side I get log 725 to the negative 1. Okay, so now by the properties, I can drop that negative 2x, and then I have log of what? Of 5 equal to, there I drop the negative 1 such that I have negative log of 7 what? 25. Okay, so this is what I get. And then from here now, you can what? You can divide by this log of 5 and that side the log of 5. So I can divide 2. So I say 2x here is going to remain, and there you have the log of 725 over log of what? Log of 5. And then here I multiply by half this side, multiply by half, and the other side multiply by what? By half, like that. And this here is just going to give me x is equal to log of 725 over, so that 2 multiplies in the denominator, I get 2 log of what? Of 5. Okay, so this here is what I was going to get. So if they tell you to what? To evaluate exact, then you can punch this in the calculator, but since they didn't tell us, just left it like that. So we can what? We can just leave it here like this. Okay, so I don't know if there's any question. Is there any question? Okay, so there's no question. So since there's no question, we are going to move on to the next one. So the next one here, we have the following, and they're telling us to what? To simplify. Now we're going to simplify, and then here we are going to apply again. We're still dealing with what? The same laws of what? Of indices, that laws of what? Logarithms, the properties of the logs, and then also the indices to help us what? To help us solve and simplify our what? Our questions. So we have that log, there we have log base 3 of what? 24, and then you're adding. So if you're adding there, what does that mean? So this here, notice that, okay, let me write it out here, plus log base 3 of what? 15 minus log base 3 of what? Of 10. So this here is going to be, notice that all of them here have the same what? Have the same base. So it means I can take them two at a go. So I'll say this will be log base 3, and then you have 24 there. So since they are adding, I can bring them back together by what? Multiplication. So this is multiplied by 15. Multiplied by 15, then negative log base 3 of what? Of 10. So when I multiply 24 multiplied by 15, I just get 360. So this here is going to be log base 3 of what? 360 minus log base 3 of what? Of 10. And then since it's subtraction, meaning that's going to be division, so I get log, keep there log base 3, and then you say 360 and divided by what? There, the 10. so I divide by 10. And this here is going to be log base what? Base 3 of 36. Okay, so this here is my what? My answer for the first part. Okay, let us now consider the what? The second one. So I raise here. So the second one is just telling us we have log base what? 2. So notice all of them also have the same what? The same base. So base 2 of 90 what? 90. You have there 98. And then you have minus log base 2 of what? Of 30. Plus log base 2 of 15. Okay, so this here is just going to be, I'll say log base what? Base 2. And then since it's subtracting, so I'm going to what? Divide. So 98 divided by what? By 30. And then you have plus log of 2, then 15 there. So here, what is this going to simplify to? So I can simplify the 98 over what? Over 30. 98 over 30. This just simplifies to. So here we have log 2. If I divide by 2, 98 divided by 2, I get 49. So that will give me 49. And then down there, divide by 2, I get 15. So this is what I get. Plus the log base 2 of what? 15. Now, since it's addition here, I can simplify by multiplying. So that will be 49 over what? 15 multiplied by what? 15. There. So this and that there, they divide. And then I just have log base 2 of what? 49 is the one which is going to remain. Okay, and there, that is what? That is my answer. All right, so let us now switch and move on to a different type of what? A different type of question. So these here had the same what? Had the same bases. So they all had the same bases. Now let us look at a concept when the base has what? Has changed. Because I'm sure you might be asking. So here we're dealing with things that have the same bases. Now what if they don't have what? They don't have the same bases. What are we going to do? So if they don't have the same bases, then we're just going to say, so like the one that follows here, we have log and there and there. And that one there, they have different what? Different bases. So let us start with log. We have log base is C there, and then A, and then multiplied by log base C of B, and then you have multiplied by log base what? A of C. So here what we want is first to have what? A uniform what? A uniform log. So we want a uniform what? A uniform log. So all of them, they have different ones. So here I'm going to change. You can change to any log that you want, but then to simplify work, I'm going to use what? The base 10. So how am I going to do this? So when I'm changing using base 10, so yeah, how you change logs is, so if I have log B here of what? Of A, then if I want to change it to base 10, so base 10, we know that the base there, you don't usually what? Indicate. So you just write log, and then you write what? You write out the value there, A. So it follows there. And then you write log here, also base. The base is 10, you don't indicate, and then you write of what? Of this base which was there, the base where you're coming from. So that would be B. So this here, it would mean I have what? I've changed this from what? From base of B to what? To base what? Base 10, like that. So base 10, we don't what? We don't indicate. It's usually just written like that. And then we have log here of C, B there. And this here is going to be log, so base 10, and then I write my B there, and then log base 10, and then I write the what? The C. You divide like that. And then the next one is log A of what? Of C. This is going to be log base 10 of what? C, and then log base 10 of what? A. So now the next thing is I can replace where this in this expression that I have. So in that expression, I'm going to have log A of log divided by log what? B there, and then multiplied by log B over log what? C. I know it's base 10, so I'm not saying it. So log, and then there you have log what? C divided by log A. Okay, so I've written them like this. Now notice that you're going to have this there and that at the same term, and then you have that and that at the same term, that and that at the same term. So this is 1, 1, 1, 1, 1. So when you multiply this, you just have 1 over 1, which is just equal to 1. So this whole expression just simplifies to 1. Okay, is there any question? Okay, so there's no question. Let's do the next one. So let us do the next one. So for the next one now, I will not use base 10. Let me show you now that you can actually, any one which are going to change. As long as it's a uniform log, it's going to work. So here we have log base 3 of 7 multiplied by log base 5 of 9 and then log base 7 of 25. So how are we going to do this one? So how do we change this one? So I'm going to change to base these others. So here I have base 3. So I have log base 3 of 7 and then multiplied by a log base 5 of 9. That's 5 there, and then multiplied by log base 7 of 25. So I write it like this. So now this here, I'm going to what? I'm going to change these other two. So this one and that one to base to base 3. So I'm going to have, this is going to be log base 3 of 7. So how do I change that one? So multiplied by, so this here, I can write it, first of all, I can write this as log base 5 of there 3 to the power 2. And then I can also write this as log base 7 of 5 to the power 2, such that I have log 3 of 7 multiplied by the 2 drops. I have 2 log base 5 of of 3 there, multiplied by the 2 drops. I have 2 log base 7 of of 5. Now I can I can change the log. So I'll change all of them to this log log base of base of 3. So I'm going to have 2 there. I write it outside, and there I'm going to have, so that will be log. I'm changing to what base? So I write the base I'm changing to base 3, and then I get the value that is there. The value there is is 3, and then I divide by log. I'm changing to base 3, and then I check the previous base that I had is is 5. So I'll put 5 there, and then I close. So multiplied by 2, and then you have log base I'm changing to base 3, and then I take the value that is there, which is just 5, and then I say log base 3, and then I take the previous base, which is just 7, like that. Okay, so this here is going to be, so log base 3 of 3, this is just going to be 1. So this here goes to to 1. This just gives me 1. Okay, so I have, this will be log 3 of 7, and then multiplied by 2, you have 1 over log base 3 of 5, and then multiplied by 2, you have log base 3 of 5, and then you have log base 3 of 7. So now here I can I can cancel out. So look, this log 3 of 5 and that one there, they divide, and then you have this log 3 of 7 and that log 3 of 7, they divide, and you just have 2 here is going to remain. So you have 1 there, that's 2 multiplied by 1, which is 2, and then 2 multiplied by the 2 there, you're just going to get, this is going to give you 4. So that is the value for this log. Okay, unless there's any question, we move on to the last part there. So the last part just tells us that we have log base 3, and then we have log base 3, and then log base 3 of 27. So in short, I'm taking the first one there, and then that one, and then the outer one. So this here is going to be, so the inside there, this inside log here, I can simplify this to be, so that is log base 3 of 3 to the power 3. And then the 3 drops. So I have 3 there. Since 3 to the power 3 is just 27. So I have, that would be log 3 of of 3. Since they have the same base, it means that is just 1. So that is 3 multiplied by 1, which just gives me 3. So there I can replace, that to be log base 3, and then log base base 3, and there inside that will be 3 there. I can replace the 3. So now again here you see I have log 3 of 3, which is just 1. So I have log base 3 of 1. And we know that when you take the log of 1, you're just going to get 0. So this here, our answer is going to be what? Is going to be 0. Okay, are there any questions? All right, there's no question. So now we look at the last part. So the last part here, we have that 2. So the thing has to solve for x. So we have 2x to the power x, and then you have 9 to the, and then you have 9 there. So what are we going to do here? So here we take the log on both sides. We have 2 to the 2x, and there you have log of what? 9. And this is going to be, I drop the 2 there, I get 2, and then you have x to the 2 is equal to log what? Log of 9. And this here is going to be, I divide by log 2 both sides. I'm going to get 2x is equal to log 2 of log what? Log 2. Then I can divide here and multiply by half, and the other side I multiply by what? Half. So this is x going to be equal to, so that will be log 2 there on top and log 9, and there you have log base what? Base 2. Okay, so this is of, and the 2 there, which you have what you've multiplied. So this is what this amounts to. All right, so this is how we do this question. So the next question here, we have 2 to the power 3x plus 1 is equal to 5x plus 1. So this here, I get the log on both sides. I get log, and then you have what? 2 to the power 2x plus 1. So that's 3x plus 1 is equal to 1. We take the same. So you have log 2, 3x plus 1, and there you have log 5x plus 1. So this here is going to be, I can drop that power, which is just 3x plus 1, like that, and then you have log 2 there. Of course, since we are using base 10 for us here, because we've chosen what to use base 10. You can use any base, but then I'm using base 10 here, which is the most convenient. So you have x plus 1 there is going to drop, and then you have log what? 5 there. So this here is going to be, I can multiply. So I multiply the 3x multiplied by the log. I'm going to have, this is going to be log 3x, and then of 2 plus I multiply with the 1, I get log what? Log 2. The other side I do the same. I'll have x log 5, and then the multiply by the 1, I have log of 5. Then I can group the ones that have the x's on the right, on the left, I mean, such that I have log x, 3x, log 2, and then I bring this the other side, it becomes negative x log 5. And then I take the log 2 the other side, such that I have log 5 minus log 2. And then I can factor out x here. So I can factor out an x, and then I'll have 3 log 2 minus log 5 there. And this is equal to log 5 minus log what? 2. Then from here, you can what? From here, you can just divide. So I have x, I'll divide by this on both sides, such that I have log 5 minus log 2 divided by 3 log 2, then minus log 5, like that. So this here is going to be my answer. Okay, so let us then continue. So what is the next one? So the next there we have, okay, so they're telling us that we must find, okay, so they're telling us to find this equation here. So the equation is, okay, let me erase there. So we have 2 to the power of x plus 3, and then is equal to what? 2, 1 minus x, and then plus what? 15 there. So how are we going to do this one here? So notice that you have this factor, which is what? Which is here. So that factor, which is just that factor, which is what? 15 there. You're adding the 15 there. So notice that we can write this 2x plus 3 can be written as 8 multiplied by what 2x. Since this here, we are just saying this is 2x multiplied by 2 to the power 3, which gives me this here. So I can write that like that, and then I can write the 2 minus 1, the 1 minus x. This here I can write as 2 over what? 2 over 2 over 2 to the power x. Okay, I can write this like that. How? You see that you have 1 there multiplied by 2 to the negative x. This negative means I can bring it down. So I have 2 over 2x. Okay, so I can write that like that also. Then I can remove, so I can now substitute back into this equation. So when I substitute back into this equation, I'll have 8 multiplied by x there, and then you have 2 over 2x, and then you have plus what? 15. We're going to have it there. Okay, then the next, I want to get rid of what? This fraction here. So getting rid of that fraction, I multiply by 2 to the power x on both sides. Then I'm going to get, so there I'll get 8 multiplied by, so 2 to the x here to be squared since I'm multiplying it on both sides. And there, when I multiply, it's going to cancel out such that I have 2 there. Okay, and then there on the 15, it's going to multiply 15 multiplied by 2 to the what? To the x. So this is what I'm going to get. Okay, next now here, what are we going to do? After this here, we're going to say, let y be equal to what? Let y be equal to 2 to the power what? To the power x. So let y be equal to 2 to the power what? To the power x. So notice that you have 2 to the x, and then you have it there as well. So now we want it to be equal to this. So what is this then going to give me? So of course, for y be to be what? Y should be greater than what? Y should be greater than 0. Y should be greater than 0. So now notice that after writing it like this, when you replace now, so meaning where there's y to the x, I can put, where there's 2 to the power x, I can put y. So that would be y, and then there where there is x to the power, 2 to the power x, I put y, and then since it's squared, the square is going to come there. This is going to be equal to 2 there plus there you have 15, and then you place it there as y. Okay, then from here we form what? We can form a quadratic what? A quadratic equation. So a quadratic equation, we're going to have this to be 8y squared. I bring the negative the other side, negative 15y, and then I bring the 2, it becomes negative 2, and then this will be equal to what? To 0. So I have a quadratic equation like that. And then it means that I can now solve this. Now let us find. So we need to find the factors. So we see here the product. When we multiply, we have 2 multiplied by, 8 multiplied by negative 2. That gives me negative what? 16. And then the sum is negative 15. So what are my factors? So when I add, I should get negative what? 15. And then when I multiply, I should get negative what? I should get negative 16. Okay, so when I multiply, I get negative 16. When I add, I should get this negative what? 15 here. Okay, so what are those two values that I'm going to have? What are those two values that I'm going to get? So you have 16 here, negative 16, and what? And 1. When you add these, you're going to get what? Negative 15. When you multiply, you get negative what? 16. So I can replace here in the equation. So I have y squared. There I'll get negative what? 16y. And then you have that to be plus what? You have there to be plus what? Plus y minus 2 equal to 0. Okay, so this here, let's keep in mind the replacement which we made. We'll come back to them. So this here I erase. So this here is just going to give us, so there I'll have 8. So 8, I can factor out 8, and y is common. So 8y is common, and then that leaves me with y minus, there I divide 8 into 16, that gives me what? 2. So I get negative 2 there. And then on the other side I can just factor out the what? 1. So factor out 1, then I get y minus 2 equal to what? To 0. So this here I'll get that I'll have y minus 2, my factors to be y minus 2, and then you have y plus 1 here. These are my linear factors. So then, which means y minus 2 is equal to 0, or 8y plus 1 is equal to what? 0. So this is y is equal to 2, or you have 8y is equal to what? Negative 1. Divide by 8, then I get y is equal to negative 1 over what? Over 8. So I have found the values of what? Or y. But then what do I want? We want this y to be what? To be greater than 0. We want y to be what? To be greater than 0. Okay. So we want our y to be what? To be greater than 0. Because when y is greater than 0, this is when this is going to be what? Defined. So now it means we get the value of y which is greater than 0. And that value of y which is greater than 0 is what? Is the 2 there. So now this implies, since 2 is, we're saying this 2x, it has to be greater than what? Than 0. Meaning we're going to reject this negative 1 over 8 and we just get the 2 there. So this means that our 2x is going to be just equal to the value of y we found to be what? To be 2. Since they have the same base, and this here is to the power 1, you're just going to say equate the exponents and you have x equal to 1. So x equal to 1 there is going to be our final answer for this equation. So this is how you would find this equation. Okay. Is there any question? Is that a question? Okay, so let's do the last question for this class. So the last question we have there as, so we have 13 to the power 2x plus 4 is equal to, you have 1 over what? 4 to the negative 3. So this here I can write as 13 to the power 2x plus 4 is equal to, so this here, this part which is having the 1 over 4, I can write this as 4 negative 1 to the power negative what? 3. Then I can multiply the what? In the exponents. So here I still get 13 2x plus 4 is equal to, multiply those exponents, you get 4 to the power 3. Okay, so we get this here. Now, what do we do next? So what we do next is we're going to take the what? We're going to take the log. So we're going to take the log of what? Of both sides. So this here to the power, this just gives you 64. It gives you 64. So you can take it like that or just the way it is. So I'll just say log of 13 2x plus 4 is equal to log of 4 to the power 3. So this is going to be, so that power drops to being there, log, then 13, there that power drops to there, and then you have log of 4. So this here is going to be, I can then look at this side. So if I multiply here, I distribute, so I'm going to have 2x log of what? 13, and then you have 4 multiplied by the log, that will be plus 4 log 13, and this is going to be 13 log 4. And then I take the ones with just the number the other side, such that I have 2x log 13, and then this is going to be equal to 3 log 4 minus 4 log what? 13. Okay, so after getting that, and then what are we going to have? So here, let me erase. So this here, you're going to just get, they have, so then I can what? I can divide here. I can divide by 2. I can divide by 2, or I can say I divide first by the log what? This log 13. So I have 2x log 13 both sides. I divide. I'm going to have 3 log 4 minus 4. Then you have log 13 there divided by log 13. Okay, and then you multiply by half both sides. You get x is equal to So half that 2 is going to come down. So you have log 4 minus 4 log 13, and then you have 2 that side, which is going to be log what? 13. Since here also we're multiplying by 1 over what? Over 2, like that. Okay, so this here is going to be what? The solution for this what? For this equation. So that there is going to be what? The solution for this equation. So I can further, if I divide this into there, so I'm going to have 3 log 4, and then you have what? 2 log what? 13 there. Then minus, you have log 13 here, and then you have 2 log what? 13. So these here can divide, and then you just have half that is going to remain there. So that would be 3 log 4 over 2 log 13, and then minus 1 over what? 2. Okay, so that is what you are gonna have here. Well, this is all for today's class. I don't know if there's any question. Okay, so there's no question. So the rest of the solutions, you can find them on the website for this tutorial sheet 3. So it's the next time we meet, we just start looking at tutorial sheet 4. All right, this has been Tutor Marius, and I'll see you in the next one. Go to log, you have 5.